So every hypothesis test ends with experimental you and I either rejecting the null hypothesis or failing to reject the null hypothesis. As strange as it may seem, we never accept a null hypothesis. P-value versus level of significance. So assuming that the null hypothesis is true, we may reject the null only if the observed data are so unusual that they would have occurred by chance at most 5% of time. Once the alpha level has been set, a statistics like sample proportion is computed. Each statistics has an associated probability called the p-value or a likelihood of an observed statistics occurring due to chance given the sampling distribution. What is happening, what we have written over here? We have basically in testing the hypothesis, we have two approaches. One we are calling it as the p-value approach, and the second we are calling it as the critical value approach. Okay, critical value approach. Okay, so when we are going with the p-value approach, we are getting p-values from the computers. We can manually also calculate it. And the critical value approach we have where we are based on the alpha which you have fixed, that is type 1 error which you have fixed. Okay, based on that value we will be deciding what is going to happen. Okay, if our value which we are observing, if it is coming in the critical region, then we would be rejecting the null hypothesis. Otherwise we fail to reject the null hypothesis. Alpha sets the standard for how extreme the data must be before we can reject the null hypothesis. 95% times you believe that you will be getting a value close to 50, है ना? जैसे nephrologist के case में it was 50, you got 42. So you have 95% times you feel that it is more or less close to that value only. So how to get that 95% value? Nephrologist has said that he has given a point estimate, na 50. So how to get that 95% value? कैसे उसका उन्होंने point estimate पता चल गया 50%. तो you have to get the 95% confidence interval, ना? Confidence interval 95% कैसे निकालेंगे? Plus minus standard error. And C, that is the confidence interval which you are wanting. Okay. Okay. So confidence level which you want, generally, if you are dealing with the say mean, okay, or you are dealing with proportion. So 95% confidence interval, the confidence level value, Z value, which we are having is 1.96. Okay. So for this proportion 50%, can you calculate the confidence interval value? निकाल के देखिए क्या आ रहा है. And let me tell you, for proportion, the standard error formula, you can write it down. Standard error for proportion. For standard error of proportion, we have the formula under root P into Q by M. Okay. So for proportion we have this formula, and for mean we have the formula for standard error is SD, standard deviation, by root over N. So is the nephrologist के case में, suppose you have studied sample of say 100, ठीक है, आपने 100 का sample study किया है, and you have got the proportion say 40, P you have got as 40. So can you calculate the confidence interval value? Confidence interval value का formula जैसे मैंने बताया था, you can write it down. It is point estimate, that is P plus minus P plus minus C into standard error. C into standard error. ठीक है. where C is the confidence level which you want. Where C is the confidence level which you want. For mean or proportion, this C value for 95% it is 1.96. For ease of calculation, you are having the smartphone, you can calculate. तो C को हम 1.96 ले रहे हैं इस एग्जाम्पल में, है ना. C is 1.96, P is given as 40. What will be the Q? Q क्या हो जाएगा? Q is nothing but नॉन प्रेवलेंस या नॉन प्रोपोर्शन बोलते हैं. तो 40 प्रेवलेंस है तो नॉन कितना हो जाएगा? 60. ठीक. तो we can have the confidence interval. So P वैल्यू हमको मिल गया, प्रेवलेंस का वैल्यू है 40 प्लस माइनस C का वैल्यू मैंने बता दिया 95 पे we take it as 1.96 एंड स्टैंडर्ड एरर का फॉर्मूला बता दिया है अंडर रूट PQ by L. How much standard error you are getting? 4.89. And when you are calculating, how much lower limit you are getting? 30.4. And upper limit? 49.5. Everyone is getting the same thing? More or less, you people are getting same result. So, based on your sample, you have got the point estimate as 40 and with a lower limit at 30, 38.4, 38, let's take 38 and 30 and upper limit we are getting it as 49, 49.5. Okay, so you are getting this 95% confidence interval. That means if you are conducting an experiment 100 times, 95% times you will be getting values in the range of 30 to 49.5. What the specialist was saying? 50. What the specialist was saying? It was 50. So you are getting this value in your range. You are not getting your value in this range. So you have fixed your confidence interval 95%. You have allowed 5% error, and you have constructed your graph. And your acceptance region was 95%. 5% was critical, and 50 value is lying in acceptance or rejection region. Rejection region. So you would be rejecting the assertion drawn by the specialist. Okay, so you will be making an inference that on a certain level of significance you are not getting a significant difference. So this is 95. What will happen if I take alpha 1%? That is confidence interval 99%. 99. What will happen? 95 is this much. 99 will be bigger one, na? So then what will happen? Let's look at this thing. This was your 95% region from 30 to 49. This is 95%. The specialist was saying 50 here. This is the critical region, extreme 5%. So you have make the inference that whatever the specialist is saying is not matching with my data set. In your data, you are not getting these values. Okay, so you have make an inference that you have your value and his value are quite different. What happened when instead of 95 I have used 99? That means I have increased the limit approximately 2% here, almost 2%, 2 some percent here, both sides, symmetrical. And a symmetrical diagram it is. Okay. we have got 49.5. He was saying 50. So what happened now? The 50 which was here in the on the border line, now it is in the inside this thing. So whenever you are making a statement in testing of hypothesis that the null hypothesis is rejected, we are getting a significant finding, always pay attention and write that you are getting a p-value at what level of significance, whether it is 95% confidence interval or it is 99% confidence interval. You have taken alpha 5% or 1% or whatever. Okay, so a thing might be significant at 5%, but it may not be significant at 1%.
What is the C at 99% confidence interval?
Come again.
Like it is 1.96.
1.96 is at this 95%. At Z value at 99, I think it is 2.58. 2.58. Yeah. So you can have these values from the Z table. Okay. So yes.
Clinician in the question had said that it is 50% of the normal value. So the normal, we're taking it as 100. It could be something else also.
No, it could be something else. What he was making, the statement was 50%. His statement that in the population it is 50%. You got that proportion he has told. It is 50%. You are not satisfied. You make done the same thing on the similar patients, group of patients. You got 40%. And you want to compare that what he has said that in the population it will be 50. You got 42. Then you have to check that thing. Okay. So one of this method is your critical region method, using the confidence interval or based on your alpha values, you can check whether it is in the critical region or it is in the acceptance region. Okay. So p-value approach involves determining likely or unlikely by determining the probability, assuming the null hypothesis were true, of observing a more extreme test statistics than the one observed. Okay. So this critical region value or the p-value approach, both are same thing, but what we are doing is that in a p-value approach we are converting this value in terms of probability, and we are saying that if a particular, we have fixed alpha 5%, if you are getting a p-value less than 5%, that means you have a poor probability that your data is matching the null. Okay, if you will get a high p-value, then you will be drawing the inference that the null hypothesis will not be rejected. How much high if you get, you will say that your null will not be rejected? P-value, how much high if you are going to get? नहीं, हम बोल रहे हैं कि कब रिजेक्ट नहीं होगा? Any value which is more than 0.05 if you have taken alpha 5%. है ना? If p-value is small, say less than or equal to alpha, then it is unlikely, and if p-value is large, say more than alpha, then it is likely. Sometimes people also say that the p-value is nothing but it is the upper tolerance limit of type 1 error. So if the p-value is less, then the null hypothesis is rejected in the favor of alternative, and if p-value is greater than alpha, then null hypothesis is not rejected. So I hope the concept of p-value is clear to everyone. Okay. Now you will not be terrified with the word p-value. Okay. Is it clear to everyone? P-value. And you have also noticed the importance of p-value. So in your research, if you are getting a p-value 0.04, 0.45, 0.05, then you have to be conscious before making a statement that it is significant, because it is on the borderline. It might be because of your sample size that you are getting this type of finding. Okay, so you cannot be very confident. The p-value will also give you a confidence that whatever the inference you are making, how strong it is. So you have to check the things if you are on the borderline before making a statement that it is significant. This we have seen. What you want to talk about, mu is equal to 2.5 population weighted birth. It's 2.5 from the sample you got 3 kg, and from the sample you are making inference about the population. What would be the null hypothesis here? H naught is such that
Birth weight in our population is the same as that. Our sample is the same as that other.
we would be making the null hypothesis. I wanted to ask that we would be making the null hypothesis statement based on parameter or statistics. We would be writing H naught mu is equal to 3, or we would be writing H naught x bar is equal to something. Mu is equal to something. Very right. So whenever you are making a statement in hypothesis testing, we make the statement about the population parameter. We do not make a statement about the sample statistics. Based on sample statistics, we check that value. So we begin with the assumption that H naught is true, and any difference between sample statistics and true population parameter is due to chance and not a real systematic difference. This is our null, similar to the notation innocent until proven guilty. That is, innocence is the null hypothesis. Next, we state the alternative hypothesis. That is the opposite of null hypothesis. H1 mu is not equal to 3. Based on our knowledge of the research question, we can have one tail or two tail assumption, and based on the data, it may be proven or may not be proven. In generally, hypothesis that the research is trying to prove, evidence is always examined with respect to HA, never with respect to H naught. So in summary, what we are doing, any type of hypothesis testing, we are doing these following steps. First, in the process of hypothesis testing, the null hypothesis initially is assumed to be true. Second, data are gathered and examined to determine whether the evidence is strong enough with respect to the alternative hypothesis to reject the null hypothesis. You have framed the null hypothesis, you have collected the data, and you are examining whether you have strong evidence against this H naught. In other words, the burden is placed on the researcher to show using sample information that the null hypothesis is false. If the sample information is sufficient enough in the favor of the alternative hypothesis, then the null hypothesis is rejected. This is same as saying if the prosecutor has enough evidence of guilt, the innocence is rejected. Okay. So you have framed the null hypothesis, you have collected the sample, and based on that sample, you are studying whether the data is matching H naught or not. If it is matching, if it is not matching, you will reject, otherwise you will not reject. So on what it is depending? This all testing of hypothesis depends on what is at its core.
We are trying to find out parameter of the population when taking a sample of the.
No, well, that is true, but what I'm asking is that, ma'am, what is at the core of testing of hypothesis? What is the main thing? P value तो है, P value किस पे डिपेंड कर रहा है? P value कॉन्फिडेंस इंटरवल पे डिपेंड नहीं कर रहा है. P value किस पे डिपेंड कर रहा है? आपके डेटा पे ना, आपके डेटा पे डिपेंड कर रहा है. इसीलिए जो बोला जाता है कि डेटा कलेक्शन इज द कोर ऑफ रिसर्च, एंड अनफॉर्चुनेटली डेटा कलेक्शन क्वालिटी इज वेरी पुअर, है ना. पीपल आर नॉट यूजिंग साउंड सैम्पलिंग टेक्निक, एडिक्वेट साइज, एंड सो जब डेटा ही अच्छा नहीं आएगा तो पी वैल्यू क्या अच्छी आ पाएगी? नहीं आ पाएगी अच्छी, है ना. सो इट डिपेंड्स, एवरीथिंग डिपेंड्स ऑन द डेटा. What type of data you are gathering? What is the quality of the data? If the quality of the data is such that it is representing the population scenario exactly, then you will be having a smaller standard error value, and then only you can say my p value is having a meaning. इसीलिए आज के nowadays people are having more emphasis on confidence interval, because p value is also a point estimate, single p value you are getting, but in interval estimate you are getting a range कि possible values ये हो सकता है, ठीक है. तो you are getting a range, okay, and then based on that range they are making an inference, okay. The reasons for rejecting H naught, let us assume that the average age in US is 50. If in fact this true unknown population mean, it is unlikely that we get a sample mean of 20. So if we have a sample that produces an average 20, then we reject the null hypothesis, that is the average age is 50. Note that we are rejecting our assumption or claim. How it is done, how you are rejecting it. Basically, in statistics, we are using distribution theory to draw these conclusions. Okay. In critical region, what we have used, that graph we have used, na? A bell-shaped graph we have used. That is nothing but that is a type of a distribution of the data. You have made a histogram. By joining the midpoints of a histogram, you are getting a bell-shaped curve, which we call it as a frequency polygon. Okay. So somehow in our parametric tests, we have the assumption that the data would be following the bell-shaped curve, normal curve. Okay. Now that curve has a name. Okay. If we are dealing with population, we call it as the Z, this one. If you have the knowledge about the population mean, proportion, the Z curve or that distribution which we are dealing with is the Z1. If we do not have the knowledge about the population variance, then we choose a small sample, and in that case the distribution becomes your T distribution, this one, T. Similarly, if you have the count observation, the distribution will change. Okay, so based on your data collection, based on your objective, what you are doing, your distribution will be changing. But the methodology for doing testing of hypothesis will not change. It will remain the same. And what was the methodology? We will come on the stepwise methodology so that you can have the clear-cut picture. So what was the core? Core is that we are framing a null hypothesis and we are collecting the data. And once the data is collected, then we are observing how well our data is matching H naught. If it is matching very good, p value is high, we will not be able to reject the null hypothesis. But if we have collected the data and it is not matching the H naught, So we will be getting a lower p-value and we will be making an inference that our null hypothesis will be rejected at the given level of alpha. So this we would be doing in any type of statement, whether it is mean, proportion, correlation, regression, anything. Okay, this is the phenomena. So these are few examples, more examples of critical region approach. Okay, so in critical region approach, we have got this. This is a one tail or two tail? Two tail. Okay, so it is a symmetrical diagram. So alpha is divided into two halves. So if the values are lying in this white region, what will happen? This is non-rejection region. Okay, your null hypothesis may not be rejected. You will not be able to reject it. And this one is one tail or two tail? One tail, right tail, and this is left tail. Okay, and in p-value we are not using critical value approach. Okay, we are using maximum probability of type 1 error. This is हमने बोला था upper tolerance limit of type 1 error. We have fixed the upper tolerance limit 5%. Any value you are getting lower than that, you are making an inference that the null hypothesis will be rejected or not. Okay, so we are having some standard 7 steps of hypothesis testing, traditional or classical method. Okay, using this 7 steps, you can do any type of hypothesis testing. So, anyone is having any confusion till now? Is it all clear? Okay. Now, I want that you people can write these things, these steps, so that it becomes crystal clear what we are going to do. This will be the core steps of doing any type of hypothesis testing. Step number 1. Step number 1. Describe in words the population characteristics about which hypotheses are to be tested. Describe in words the population characteristics about which hypotheses are to be tested. Number 1. Okay. That what I am saying. That parameter. What is that parameter? In your research question, आप thesis में जो कर रहे होंगे अपने या articles जो भी लिख रहे होंगे, in that what would be the what is the characteristics you are measuring? Can you identify from your research question? Thesis में जो लिख रहे हैं, characteristics of the population. You will be making inference about the population parameter, na? So what parameter you are interested in? Response rate. Madam I said response rate. और कोई क्या दिख रहा है? Biomarkers. Okay. Obesity induced or not. So what is happening is whether it's a type of a how many individuals are there who have been obesity. Obesity is there. That means you are talking about some proportion. How many individuals will be there where obesity will be induced? P would be there. And some type of prevalence. Very right. And some others. Safety is not generally a characteristics. Always whenever you are framing a hypothesis or you are doing a research and you are framing your objective, it is an important step that your objective should be measurable. It's a very important condition in while framing your objective. It should be measurable. Okay. adverse effect in terms of so many proportions where individuals were there who have reported a ADR, है ना, like that. So it's a proportion. Characteristics is proportion. Okay. So anyone else in your research objective? Comorbidities is present or not? Yes or no? Number, count, observation. So many were there who have comorbidities. So many are there who have comorbidities not there. Okay, it's a type of a proportion. Okay, many individuals who would be there who would be interested in some type of mean average values. Is anyone calculating the average values? So these are very fine things in our research. Okay, what you are measuring, whether you are measuring proportion, whether you are measuring comparing your means, whether your problem is of relativeness, all these things you have to check. So first thing which we have written is that describe in words the population characteristics about which hypotheses are to be tested. So population characteristics can be proportion, it can be correlation, it can be regression, anything. First step is that. Second step, write it down, it is state the null hypothesis. That means H naught. You have to state your null hypothesis, that is H naught. Second step. Third step is that state the alternative hypothesis, that is HA or H1, and identify whether it is you are framing it as a one tail or a two tail. So this is the third step. कोई भी hypothesis testing कर रहे हैं हम लोग तो ये steps follow करेंगे. पहले है describe in words the population characteristics about which hypotheses are to be tested. Second, state the null hypothesis H naught. Third, state the alternative hypothesis HA or H1. Check whether it is one-tailed or two-tailed. Fourth step, fix the amount of risk you are willing to take. That is, choose level of significance. Right on the fourth step. Fourth step is that you have to fix the amount of risk you are willing to take. So I am willing to take only 1% risk. Okay, 1% risk only I am willing to take. That means I want a confidence interval of 99%. I am willing to take a risk of 5%. So my confidence level would be 95. So in general, what you want? We want a very high confidence level. So if you want a very high confidence level, that means you want a very low alpha. Type 1 error, you want very low. And what happens that if you are trying to have a very low level of alpha, so you have told your statistician that I want an alpha of 1% only, sir, and tell me how much sample I have to study. And he said that if you want to be so sure, then ideally you should cover so and so much population. Okay, you have a budget of 200 samples and he has told that you have to cover 900 samples. So what happens? Because of the time or money constraint, you may not be able to cover so many individuals. So you will say that, sir, I don't have so much money, so we can allow some more errors. So alpha, he has said that okay, now you can take 5%. Okay. Many times people happen that, sir, I don't have time, I don't have money, and I want to study very small sample size. Okay, so he is saying that I am willing to take alpha 10%. That means only 90% times I want to be sure. So what happens? Your inference will become very vague. Okay, so you have allowed 10% on either side of the error. So what happens? That the you are it is like that you are saying a patient that your disease incubation period in general, if it is between say 5 days to 10 days, you are saying that कि एक महीने नहीं तो साल भर में ठीक हो जाओगे, 6 महीने या साल भर में ठीक हो जाओगे. तो बोलेगा डॉक्टर साहब क्या बोल रहे हैं, साल भर में तो ठीक हो ही जाएंगे. So it will become vague. Okay, so ideally we allow a small type 1 error. Okay, so this is the fourth step. Fix the amount of risk you are willing to take. That is, choose level of significance, alpha. Now, fifth step, display the test statistics to be used. Test statistics, that means you are developing a statistics which you are testing it. So in general, whatever the distribution we are using, more or less we are using this formula: observed value minus expected values divided by standard error. Okay, so we are using this value, we are calculating the type 1 error. Observed values minus expected value divided by standard error. Whether you are using a z, whether you are using t, whether you are using chi-square, more or less in general we are using this formula. Step number 5. Step number 6, compute all quantities in the test statistics and compute the test statistics itself. Okay, so we would be computing all these values: observed values, what is in our data set which we are observing; expected values, which should expect from our data; and what is the standard error in our sample. Okay, now state the conclusion. The conclusion depends on the level of significance of the test. Also remember to state your results in context of specific problem. Okay, so this is step. Compute all quantities in the test statistics, this one, and compute the test statistics itself. What we are doing in the sixth step is that you can precisely write it down, that if this is the value which you are calculating, you are calculating this value. So if the calculated test statistics value, you can write it down. If the calculated test statistics value, is more than, if the calculated test statistics value is more than the tabulated value, we will reject the null hypothesis. Otherwise, the null hypothesis is not rejected. And once you, in the 7 steps which I have written, state the conclusion. Whatever you are getting, if you are getting significant value, you would be saying that the two things are significantly different. It can be in context of mean, it can be in context of relativeness, then you will say that association, like that. So in the 6th step, what we are doing, we are calculating the value based on the test statistics which I have given: observed minus expected divided by standard error, and this is the tabulated value. From Z table at alpha 5% you are getting 1.96. सिमेट्रिकल है तो कोई भी हाफ पढ़ लेंगे, बीच में से काटेंगे, एक जैसा ही है, चाहे ये पढ़ लें चाहे ये पढ़ लें. टू टेल्ड है तो कोई भी पढ़ सकते हैं, सिमेट्रिकल है ये ग्राफ. तो when we are getting this value 1.96, and from your tabulation, observed minus expected divided by standard error value, you are getting a value 2.1, what will happen? Observed, आपकी जो कैलकुलेटेड वैल्यू है वो 2.1 है, ये 1.96 है. 2.1 इस साइड लाई करेगा या क्रिटिकल रीजन में लाई करेगा या एक्सेप्टेंस में लाई करेगा? क्रिटिकल रीजन में लाई करेगा ना. ये प्लस इन्फिनिटी इधर जा रहा है तो इधर लाई करेगा. तो इधर लाई कर रहा है, इसका मतलब कि whenever the calculated value is more than tabulated value, it will always be in the critical region. That's what we have written. Okay, so whenever it is your value, calculated value is more than the tabulated value, it will always be in the critical region. In this case, normal distribution, we have the tabulated value as 1.96. If we have the idea about the population, we are dealing with proportion, then we are using this curve. Otherwise, when we are dealing with the mean, we are using a slightly more well dispersed curve, which we are calling it as a T. उस T के लिए ये value थोड़ा अलग होगा. At alpha, we will see what value we are getting. I hope the concept is clear. Thank you everyone.